All right, to get it started here, we're just going to run the programs right away because it is going to take a while. So we're just going to have this running. We're going to let it render a frame or so, and then we'll explain in the meantime because, like I said, this is going to take a while. All right, that looks good. Okay, so while this is running, let's start with the code that well, actually, first off, I should say we're using YOLO v3 to perform this comparison. YOLO v3 Tiny to be exact. On the first system that we're running on is a PowerPC based system. We're emulating a PowerMac G3 from the early 2000s. And the second system, we're running a Longsun 3. It's a MIPS64 based processor to do the second detection on. Key difference first is one, we're using Python 2.7.6 on the older system, and on the newer system, we're using Python 3. The older system has Python 3, but it doesn't contain OpenCV and the relevant libraries needed to make this stuff actually happen. And see, in the meantime, we got some stuff going down. We'll see some output on the MIPS one in a little bit. See, it took 4.81 seconds just to load the model on the old system. In the meantime, let's check out, there we go. The first part of this is setting up the Python interpreter. Loading the model is actually pretty quick, but let's check the code that we're running on the MIPS side first. Just open with Notepad here. Just some basic, simple Python code. You can find examples like this anywhere online for both. You'll see they're very similar to each other. Since this is using Python 3, we're just importing CV2, NumPy time. We're reading the time it takes to load the model. We're checking the time it takes to render each frame. In the end, you'd output the total time it takes to render, but as you'll see, we've never really reached the end of rendering this 5-minute video because this just would take an unreasonably long amount of time. But very simply, we're taking the video, getting the width, frame, FPS, loading it into the model, running inference on every frame of the model, and we're outputting the video as an MP4 for this one. And then let's see here, for PowerPC. Very similar, but slightly different. This time, because we're running this on Python 2.7.6, we have to use the darknet wrapper for YOLO. There's a lot of the OpenCV functions that YOLO uses are implemented in Python 2.7.6. So here, for example, we have to comment out the cat prop FPS. This stuff didn't exist yet. So we just manually hard-coded some FPS values, some width and height. Same thing, we got to load a little bit extra data, cocoa.data, something you don't have to load from the other one, but we're using these specific darknet wrappers for this. To get this running on the PowerPC system, it was a lot more labor intensive. I had to actually take the source that I cloned from Git for the darknet and make some modifications to make it work with this sample code, because this sample code is using Python 3 with the darknet wrapper that I got this from, but I'm using Python 2, so had to make some adjustments to make that work. Other than that, same thing with reading the time, getting the time to load the model, time for frame detection, running its frame detection. You'll see what the outputs look like. So that is the code for it. Now, while this is running its first frames, as you can see, we processed frame 0, 116 seconds on MIPS, 140 seconds on PowerPC. Now, you might think that this is really close to this time, but there's also some errors with this older model, but it is running. So to see the outputs, first off, we have an example here. So this is MIPS. So these examples, so for this MIPS example, I rendered about 310 frames. It took about just over 7 hours, had this running overnight. So at 30 frames a second, this gave me about 10 seconds of inference. And you can see with Python 3, it actually works pretty well without using the darknet wrapper. Quick little 10-second video here. Very nice, actually. And we're going to get some interrupts going in this because you have to wait for a full frame to process before the interrupts recognize. So we're just going to see a 1-frame example, but you can see here that it is working. Now, with the output for PowerPC, since it's older hardware and it's the old wrapper, and I had to make some modifications, so it's not working perfectly, but I don't know if you can see, you can see that the detection is happening. Just the quality got extremely messed up with this. See, the first couple frames are okay, but the quality did kind of degrade. Now this 10-second render on the PowerPC took a little over 10 hours to do. So this was a lot more labor intensive to get this one done, or a lot more waiting, I should say. And even though it doesn't fully look good, you can still see that the object detection was running. So let's see here. So we interrupted our processes. So what we want to do now is, what do we call it? Oh, the other thing about this system is that MP4 was not recognized. So my input video was MP4 format. I had to convert this to an AVI. I used a FFmpeg to convert this to an AVI on my my WSL instance, and then I SCP'd it over. So actually, first off, we're going to run SCP here. We're going to get this video on and just see what the one frame that it did was, just to prove that it's working. Let's transfer that over. And then same thing here. I already have a command ready for this. Just make sure it output. Oh yeah, there it is. As you can see, it breaks in the terminal on the MIPS instance, but that did work. So let's see here. Here we go. So here's our one frame of inference on this one. You can see it did run it on this frame. This is the one frame that it processed. And let's see what it looks like on the PowerPC one. It's the same as what we expect. If we allowed it to go a couple more frames, you'd be able to more clearly see it. Because it is a lightweight model, so it's not the best at detecting objects. But you can see the filters that it applies to the videos to actually make the detection happen. But that is just one frame. And notice that one frame with all the AVI headers, 41 kilobytes. One frame of the MP4, 38 kilobytes. Still quite large for what it is. But all in all, you can see that everything's working. The inferences were running to varying degrees of quality. One might be working better than the other, but it was confirmed running. And you can obviously see that on a newer 64-bit MIPS system. It well outperforms a, I believe this PowerPC architecture is 32-bit. So it definitely outperforms a 32-bit PowerPC PowerMac G3 from the early 2000s.